So the last presentation you saw was starting with nomenclature, alkanes, alkenes, alkynes, cyclic compounds, things like that. And now we're just going to build on that by moving away from hydrocarbons and changing the functional groups that are seen. Okay. So we're going to start with, all right, very simple, very easy to start. We're going to start with alcohols. All right. Alcohols, functional group. We'll do it this way. We'll do that. Alcohol functional group is an OH. The ending or suffix is going to be OL. Okay. So my functional group is an OH. And my ending is OL. We'll have aldehydes. Okay. The functional group is the following. C double bonded to an O, bonded to an H, bonded to some carbon chain or hydrogen, something else. Remember, R stands for a carbon chain. Al, it could be a hydrogen too, is the ending. Al is the ending for an aldehyde. Ketone. Okay. C double bonded O should be there as a functional group. And the carbon has to be bonded. This time, no hydrogens possible. Has to be bonded to two carbon chains. And they're not the same carbon chain, so sometimes they note them like so. And the ending for that is ONE. And we're going to go over every single one, but I'd rather give you the table first. Okay. We got a carboxylic acid. It looks like the following. C double bonded O, bonded to an OH. That C is bonded to an R. And the ending is oic acid. Okay. And we'll go to esters, and then I'll worry about amines on their own. Esters. And we'll do esters, and then we'll do ethers and amines on their own, because I want to stick with these guys that belong to okay. And the ending is O8. O-A-T-E. Okay. So let's talk about these. We talked about how to name them. You have to count your longest carbon chain. Okay. And then you look for your functional group. So let's start with our alcohols. All right, let's start with the alcohols, because that's the first one I drew up there. So you have a carbon bonded to a carbon, bonded to a carbon, and bonded to a carbon. And we'll throw an OH on that first carbon. Okay. This is an alcohol. I know it's an alcohol because it has that OH on it. It's no longer a hydrocarbon. But the rules stay the same. Count your longest carbon chain. 1, 2, 3, 4. Okay, so the prefix for 4 is bute. All of them are single bonded carbon to carbon to carbon, so our middle is AN. And since I'm an alcohol, I look at my endings, and it becomes butanol. I have to distinguish where the OH is, shortest distance. This would be 1, 2, 3, 4. That's 1 butanol. If the hydroxide was on here or here, they would still be 2-butanol. If the hydroxide was over here, that's also 1-butanol, because again, you count the shortest distance. Okay. So let's try another one. We'll go right here. Let's do a 3-carbon one. And we'll put the OH there. And again, we count our longest chain. 1, 2, 3, prop. All single bonded, AN. Propanol, OL, because of the hydroxide. Put a 2 there. So this is 2-propanol, also known as, and we know it as rubbing alcohol, isopropyl alcohol. Okay. Isopropyl alcohol, because the OH is on the second carbon in a propyl chain. And if you remember from our last one when we were looking at side chains of propyl and butyl, and then we had sec-butyl and we had isopropyl, that's why it's also called isopropyl alcohol. Okay. If there is 2 alcohol groups, let's say, in a carbon chain, so let's look at it from the skeletal structure way, and we go, all right, and I said, okay, there's an OH here, and there's an OH here. How would we name this? Well, first we want to count our carbons. All right, so we have 1, 2, 3, 4, 5, 6 carbons. So it's definitely a hex. And this is exactly how to do it. It's like figuring out a puzzle. So there's 6 AN. I have 2 of them though. So what do we call it? We call it a diol. Now, since I'm going to put a D there, I don't need the N anymore for pronunciation. Hexa, di, all. And then say where they are. If I go this way, it's on the second carbon. If I go this way, it's on the second carbon. So it doesn't matter. 1, 2, 3, 4, 5. So it's 2, 5, hexa, diol. Okay. Questions on alcohols? And you would do the same thing if it was a cyclo. Okay, like we did cyclohexane or whatever we did in the last video. If it was cyclic and it had an OH, we'd call it cyclohexanol. Okay. So let's move on. All right, we'll look at our aldehyde next. Let's take a look at our aldehyde. So an aldehyde needs a C double bonded O in it. Okay, this C double bonded O, let's make it 5 carbons long. 1, 2, 3, 4, 5, boom, boom, and you already have 4. Okay, a C double bonded O, like so, is known as a carbonyl carbon. We'll be talking a lot about carbonyl carbons and things like that. Okay. But it's the same principle. Okay, you count the longest carbon chain, 1, 2, 3, 4, 5. Okay, it's a pent. They're all singly bonded. Put an A, N. All right, and in our case here, it's pentanal. A-N-A-L. Pentanal. All right. You don't need a number. You don't need to call it 1 pentanal or anything for aldehydes, because it always has to be on the end since this is the functional group. Okay, so no numbering is needed. You do not have to call it 1 pentanal. because it's at the end. Now, the inside joke for every organic chemist ever is this one right here. Everyone loves a 4-carbon aldehyde. All right, because it is 4 carbons, but, AN, all single bonds, AL, but anal is always the inside joke between all organic chemists. Okay, so butanal would be a 4-carbon aldehyde. All right. Now, a sister molecule, and all of these that we're talking about here derive from our alcohols, and we'll talk about that when we get into alcohol reactions and things like that in Orgo 2. They can all be derived from different alcohols. But let's move on to our ketones. Ketones cannot be at the end because they have to be. The carbonyl carbon has to be surrounded by carbons. Okay. The carbonyl carbon has to be surrounded by carbons. So this would be propanone. Propan, O-N-E, propanone. 2-propanone if you want to call it that, but it's not necessary because that's the only place it could be. Continue on. Okay. Put it there. We got pentanone. Now we need a number. Okay, 2-pentanone. And just to show you how it looks, okay, just to show you how it looks as a line structure. So let's do 5. 1, 2, 3, 4, 5. This is 5. 1, 2, 3, 4, 5. And off the second carbon, there's a double bonded O. It would look like that as the skeletal structure from the line structure. Again, we would have to draw all the hydrogens in. And again, being a biochemist, that's the way I'm used to drawing everything out to see it. But organic chemists are going to make it simple. And either way is acceptable. Okay. Carboxylic acids. Okay. Same principle. It's kind of like the combination of an alcohol meets an aldehyde. And no numbering is needed. Because it always has to be at the end, because here's our functional group. Okay, so again, we count up how many carbons. We have 7. It's hept. They're all singly bonded. Hepta. And now we add our ending, oic acid. Heptanoic acid. 7 carbons, hept, all singly bonded. A, the end there for pronunciation. Oic acid, because here's my acid functional group. Okay. So it's really a giant puzzle of figuring out what is my functional group and matching it to its correct ending. We got esters as our last one. And we're going to look at with this grouping. An ester has a carbonyl carbon bonded to an oxygen, but then bonded to another carbon chain. Okay. So this is an ester. All right. If you want to draw in all the dots, there'd be 2 there, there'd be 2 lone electrons there, and we'd be set up. Okay, there's 2 parts to naming esters. There's the part that actually has the carbonyl carbon in it, and then there's the part over here that's the extra. Let's focus on the one with the carbonyl. That's going to get the O8 ending. So there's 3 carbons. This is propanoate. Propanoate. But I have to mention this over here. This is treated as if it was a side chain. So this would be ethyl propanoate. It's not propyl ethanoate, it's ethyl propanoate. Esters are important. Esters is what gives food its flavoring, or more specifically, gives food its smell. So whenever you're going to take Orgo Lab, if it's with us, you're going to make banana oil. You're going to use wintergreen oil. Those are all esters. Esters are formed by reacting a carboxylic acid with an alcohol. You don't have to worry about that right now. Okay. All right, questions on these 5. Naming them. This one's, I think, the most tricky, just because there's that little extra part. But as long as you know what to do with that little extra part, you're okay. No questions, I'll move on. All right. Now let's move on to ethers. And we'll get more into ethers later on, but let's just get a general naming for them. Ethers look like this. No carbonyl carbon, a chain of carbons, an oxygen, and then another chain of carbons. Okay, so let's say it looks like we have this. Okay. Now we'll put one more on there. Why not? Just for fun. Now there's 2 ways to name this. It's actually 3. To me, my favorite way to name it is name these 2 as side chains in alphabetical order and put the word ether at the end. Okay, so I have ethyl, propyl, ether. Another way to do it is take one of these, doesn't matter which one, okay, and put the word oxy at the end. So this could be ethoxy propane, or you could have called it propoxy ethane, but usually the shorter chain gets the ethoxy. To me, I like this method, ethyl propyl ether, but this is the functional group for an ether. Treat them as side chains, put the YL on, boom, ether, ethoxypropane. We're not going to worry about cyclic ethers and things like that just yet. Cyclic ethers are known as epoxies. And there's the oxy coming into play. Okay. So those are ethers. And then one more, I want to talk about our amines. All right. Amines. Functional group. An R bonded to an NH2 group is an amine. Now, it could be an R bonded to an NH2 group. It could be an R bonded to an N that's bonded to an H that's bonded to an R, so on and so forth. Okay, we're going to get more into amines later on in orgo. Let's just focus on an amine, an R chain, some sort of carbon chain bonded to an NH2. Okay, so let's do it the skeletal way. All right, let's do it like this, but right there's an NH2. So I've got 1, 2, 3, 4 carbons. Here's the first, here's the second, here's the third, here's the fourth. That's not a carbon there because the point is not there. It's saying it's bonded to an NH2. 4 carbon chain, bute, AN, butan, amine is one way of naming it. That's for what we call a primary amine because it's only bonded to 1 carbon. Okay. And that works. That's a nice IUPAC way. Another way of writing it is 1-amino butane. Now, I'm going to tell you that I like this way. And the reason I like this way is because this could be used for this NH2 being anywhere on the chain. All right, so if I had, let's do this again. Okay, but now the NH2 is coming off here. I've got 1, 2, 3, 4, 5 carbons. Okay, so 1, 2, 3, 4, 5 carbons. I would call this 2-amino pentane. Because you can't call it pentanamine because that means it's at the end. I guess you could squeeze in a pentan-2-amine would work. Put the 2 in front of it. But I like doing the amino personally. But again, both are correct for amines. Okay. If it was in the middle, well, we'll talk about that at another time when we cover amines and get into more naming of amines, amides, amines, and everything like that. So then raises the question, what happens if I'm just not one functional group and I have multiple functional groups? What if I had C bonded to a C, double bonded to a C, bonded to a C, bonded to another C, and an OH? Okay. How would I name this compound? Too many. And there we go. Now I have 2 functional groups. Well, nothing changes in counting up the carbons. It's definitely pent. Since I have a double bond in it, my middle becomes En, and I do have an OL because I'm an alcohol. So how do I name this? Well, you count the shortest distance to something that's different. 1, 2, 3, 4, 5. Like so. On the third carbon, 3 pentan. And here's where I was saying that this new way comes into play. Makes it easier. So this would be 3 pentan 1 all. Okay. And that makes sense. I mean, the middle is based on the bonding. So I do have a different functional group, but that's where the E comes. Well, what if I had this? What if I had this? Okay. So I count up my number of carbons. 1, 2, 3, 4, 5, 6 carbons. From right to left. Now, 6 is hex. They're all singly bonded. Okay, hex-an. Is it hexanoic acid or is it hexanol? Well, that's where the slides come into play. Okay, and on the slides, it's actually slide. I know there's a lot of slides in this, but there's a lot of examples in that. And, you know, I took like 3 different PowerPoints and combined them into one so you have enough examples to look through and everything like that to see all the different ways. But if you look at slide 125, there's a little sheet in there. A little cheat sheet. And what this little cheat sheet tells you is the order, who takes the highest priority in the naming. And nothing beats a carboxylic acid. Then there's an ester. Okay, then there's your aldehydes. And you could skip these others we're going to hit during the semester. But aldehyde, ketone, then your alcohols, then your amines. How about an alkene ranks over an alkyne? 2 over 3, then an alkane. And ether's way down here. Then you got a little alkyl halide, which means, okay, I put bromine or iodine or chlorine on an alkane. Okay. So you would have to follow this priority. So if we look at the table and we say, okay, carboxylic acids go over, rank over. So this is the winner. It ranks over a hydroxide OH. So we call this hexanoic acid. But I still have to tell you that there's an OH on there. Well, we don't call it an alcohol. We don't say something OL or something like that. It's a hydroxy group then. If it's not the main functional group, I'm no longer an alcohol. I'm really hexanoic acid. But on the 4th carbon, I have a hydroxy. So it'd be 4-hydroxyl. Again, if I could spell today. 4-hydroxyl hexanoic acid. Okay. Let's look at another example of one of those. Let's do this. On this end, I have a double bonded O, and on this end, I have an NH2. So off of this carbon here, I have a double bonded O. So this is, you know, if you don't see it this way, try drawing it out the long way. So I have 1, 2, 3, 4, 5 carbons. Okay, because that's bonded directly to that. This carbon here is bonded directly to that. All right, so 5 carbons. 1, 2, 3, 4, 5. On this end, I have an O, double bonded OH. On this end, I have an NH2. Okay, I look at my list. Aldehyde versus an amine. Aldehyde wins. So this is going to take precedent. Okay. So how would we name it? 5 carbons, pent. ANAL. The AL for the aldehyde, the A for all singly bonded. Got to talk about this one over here. How about a little 5-amino? Okay, 5-amino pentanal. Let's try another one. Okay. Make sure we have all our, that's 4 bonds. That's 4, that's 4, that's 4, 4, 4. Okay. How about you take a second and try to name that? How about we take a second and try to name this one? I got 3 of you watching according to YouTube, which makes me semi-concerned, or hopefully everybody's working or decided to go outside today. I'll give you a couple minutes or a couple seconds here. So, if we were to do this, okay, we look for our functional groups. I've got a little chlorine hanging out over there. I've got a double bond here, and I've got a double bond that's bonded there and there, so we know that this, based on our list, is a ketone. All right, I know that's a ketone. How am I going to number my carbons? Well, shortest distance, carbon number 1 has the double bond, so that's the shortest distance to something that's different. Okay, so we have 6 carbons. We know it's going to be a hex. I know it's going to be En because it's double bonded. Since I'm a ketone, I know my ending is going to be ONE. So we're going to have some sort of hexanone. And I've got a halogen on number 5. And the way we represent halogens, also known as alkyl halides, is whatever it is, where it is, you put an O at the end. Chloro, bromo, iodo, fluoro. Okay. Now the thing is, I have to say where our double bond is. All right, so we're going to say it's 5-chloral, 1-hexane. And my ketone is on my 3rd carbon. So 5-chloral, 1-hexane, 3-one. Okay. Yep, so the 3-one tells you where the ketone is. On the 3rd carbon, it tells you that on the 3rd carbon, there's a double bonded O. The ONE ending is for ketone. Okay. And that's where that comes from. Now, we've done it from pictures and writing the names. How about if we were given the names of compounds and had to go backwards and draw it out? Okay, so what if I had like 2,4 di, and I kind of did this. I'm just making up off the top of my head. We'll see if it works, if it's really the IUPAC name. How about 2,4-dibromo, 3-methyl, okay, so 2,4-dibromo, 3-methyl oct and al. So how would you attack this? All right, how would we attack this looking for the correct answer? Well, I would start with just my carbon chain. This is the important part. This is the toppings on the sundae. This is the important part. Eight carbons long. I'm going to do it this way. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Octan al tells me it's an aldehyde, so that means on this carbon right here is going to be a double bonded O, and it's assumed the hydrogen is there. So here's carbon 1, here's carbon 2, here's carbon 3, 4, 5, 6, 7, 8. That's a terrible 8. 8. On the second carbon, there's a bromine. On the fourth carbon, there's a bromine. On the third carbon is a methyl group. That looks like an I. I don't want it to be an I. There we go. So, this is 2,4-dibromo, got it. 3-methyl, got it. Octan, 8 carbons, got it. Al, and we don't need a number because octanal can only be at the end. Let's try another one. How about, let's try this one. Propyl ethanoate. I think we already did that one. So let's do propyl methanoate. Sure, why not? So propyl methanoate. Okay, O8 tells me I am an ester. So I know I'm going to have this in here. C double bonded O, O. Propyl is telling me I have a 3-carbon chain on the other side, where this is not. Meth means I only have a 1-carbon chain, so there it is. Propyl methanoate. Okay. Common organic compounds now that you have in your everyday life. What the alcohol that we drink is ethanol. I already did isopropyl alcohol. This right here, which we would call methanal because it's an aldehyde, but it's only 1 carbon. This is formaldehyde. Propanone, which is our simplest ketone, is acetone. You know it as acetone in your everyday life. You should be able to pick up packages now, food, drinks, chemicals, whatever it is. And I don't mean you're going to be able to draw out all the structures, but at least you'll be able to see and understand what the functional groups are. You should be able to look at the ending. You should be able to look at the number of carbons. You should be able to do that and have a general idea of what your compounds look like. In biology, when I taught up at Keystone, they didn't have any chem degree. They still don't. But, okay, what they had was a whole bunch of biology majors who used to give me flack and say, why do I need to know chemistry? I'm going to be a biologist. Now, I got my undergrad degree in biology. I got my master's degree in biochem. And it didn't dawn on me until like my second semester in grad school that, yeah, I guess we kind of need chem to have biology. So I would draw this when we did acid bases. And say to them, I don't need a double bonded O there, I need an H actually. Say to them, well, what is this the general structure of? You know, what is this the general structure of? And they'd look at me and I said, well, you didn't do these yet? And I said, well, okay, well, let's look at it. In organic chemistry, a carbon bonded to an NH2 is an amine. And a carbon bonded to a COOH is a carboxylic acid. Because this is really this. If you want to break the COOH down and take it from the inorganic way to the organic way, it looks like that. This is our carboxylic acid. And if we want to do it for pronunciation purposes, this is an amino acid. General form of an amino acid. Which then I would carry on. Well, what's the purpose of an amino acid? Well, it would make proteins. How does it make proteins? Well, we do peptide bonds. Well, how do we do peptide bonds? Well, we link the C terminus, which is a biology term, to the N terminus, which as an organic chemist, biochemist, and all of this other stuff, we know it as a carboxylic end and an amine end. But we're going to link this COOH to that NH2, driving water off. Taking one of these and that and driving water off. To make your peptide bond. Well, what are you really doing? This is a Lewis base end. This is a Lewis acid end. This has a lone pair and can bond, so on and so forth. That's why they're attracted. You're making a peptide bond. Where does this happen? It happens in the ribosomes. It happens in the rough ER, where the ribosomes are. And that's how you could tie all of this together. So putting your courses and saying, well, chemistry is stupid and dumb. Well, listen, the deal is, long after biology is dead on this planet because the sun exploded and burned it up, this rock will keep moving around and it'll still have, all right, as long as it didn't explode. But even if it exploded, its little pieces in the chemistry are still going to exist. So any biologist worth their grain of, or their weight in salt, I should say, shouldn't tell you that, well, this is just biology. We're not going to really worry about the chemistry. You have to worry about the chemistry. The chemistry is what's making the biology. It's what's making that glycolysis happen and what's making the, cell signaling happen and the ATPs and, action potentials and all of that fun stuff. Okay. Now, that being said, that's it for nomenclature. Your exam will be on essentially that first set of chapters we did and nomenclature. I am thinking for the exam, how about Wednesday? Wednesday would be, I believe, the 17th. It'll be on Blackboard all day, which will give us Tuesday to go over any review questions. Okay? That's the first thing. So this is going to be exam 1. Now, we only have a few weeks left. And I got your feet wet, and I did it this way on purpose. Okay, so listen, and, we can discuss this, but I just want to let you know. We are done the first week of July. That leaves us like 3 weeks, and we have about 2 or 3 more exams to get in after this first one. I did it this way so that you would get comfortable with virtual lectures, me being here. Okay? Now, what I'm going to tell you is we will still meet live every Tuesday, Thursday. I'll go over any questions you have on Tuesday for the exam. However, lectures are going to start getting posted as non-live lectures to watch at your leisure because for 6.5 weeks, we can't just lecture during the live period. That doesn't mean I'm not going to come live. That doesn't mean I'm not going to talk about stuff live. That doesn't mean I won't go over the homework with you guys. That doesn't mean that at all. What it means is I'm going to have videos posted up there about, let's say, stereochemistry and chirality. So if you haven't clicked the little bell, okay, besides subscribing, and click the little bell, that you'll get a notification every time, okay? Every time you'll get a notification that I've posted a new video. But I'm going to expect you to watch those videos on your time. I don't know. Maybe every other day I'll have a video up. It depends on when I have time to do the lectures themselves, because I don't have them made up yet. Okay? So your big thing is review your stuff for Wednesday. But before Tuesday hits and questions, I'll have the next presentation up there. I'm thinking Saturday or Sunday for you to start watching, because it's going to be, you know, back to back to back weeks essentially that you're going to have exams. Okay? All right. For homework for this, look through the book again, look in the different chapters. So if you look in the back and you say go to a means, it'll have how to name and means and everything. The PowerPoints do a pretty good job and all of that also.